Greetings, this is Tim Gusukuma, and today we are going to be looking at exponential versus linear growth, so I can give you the notes so that you can do this problem on your own. The basic thing you need to know about exponential functions, like this red graph on top, that is 2 to the x, is that these functions have a variable, our x, that is an exponent, so it's 2 to the power of x. This is drastically different from our typical function we like to think of, a linear function, which would be 2 multiplied by x, the graph on the bottom, or the table on the bottom. Now, when you look at the differences here, the core difference between these is as we change from y value to y value in an exponential function, we are multiplying to go from one number to the next. And as we are changing from value to value, y value to y value in a linear function, we are adding to get from one to the next. So on the red, and starting at 1 in the middle at 0, to go from 1 to 2, we multiplied by 2, and then multiply by 2 again to make that 4. So if we had the third value written, that next value would be 8, or 4 multiplied by 2. And that again is different from our linear thinking, where we say 0, 0 in the blue table, then to 0, 2 means we added 2 each time, and then from 2 to 4 means we added 2 again. So the third value there would be 2, or the third value there would be 3, 6. Again, adding 2 to get from one y value to the next. So the graphs of these two again look very different. Our linear blue bottom function there is going at the same rate each time. Every time we move over 1, we move up 2. That gives us a slope of 2. We're always adding 2. Again, our typical linear function, the way we like to think of things, always adding the same amount. But we change our thought for exponential functions because in this case we do not add, we multiply by the same amount every time we go to the right, which does mean we divide by the same amount every time we go to the left. So as we look at this function in red, you can see it flattens out towards 0 and actually will never cross the x-axis. But as we go to the right, we're going from 1 to 2 to 4 to 8, which is marked almost at the top, and then right after that a jump all the way up to 16. And so this creates a much steeper curve than we're going to see in a linear function. This is a picture of a Washington Post graphics on the coronavirus, in which case it's marking how many cases we have in the United States. And you'll see that if we look at this graph over time, that this is very much an exponential curve, which does mean if things progress the way that they are going, we will have everyone infected in a short amount of time. That's why we're currently doing our social distancing. We're trying to slow the spread so that rather than watching this exponential rate grow very quickly, we actually want to give us time, give scientists time to come up with a working vaccine or other countermeasure that will help prevent death. For future reference, because you will probably need graphs, and this is the best place online I know of to graph, you will want to know, memorize, bookmark, otherwise mark, remember the website desmos.com/calculator. This is a great place for us to be able to graph some of our answers and our problems and our functions as we continue going forward. So to begin to answer this problem, the first thing you need to do is analyze the x values and be sure the x values are changing at a constant rate. So our x values, we actually want to have a linear change. That means we add the same amount every single time. So I've marked here in red as we go from 9 to 17 to 25 to 33. You'll notice that the change in this case is that every single time we are changing, we are adding 8. And really that's a good thing. Having our constant change in our x values is going to make this analysis pretty easy. If we don't have that constant change in the x values, then we kind of have to guess at what would be halfway in between and again see if our changes would be consistent. From here, I'm now going to look at how the y values are changing, and my two choices are linear or exponential, so that means between each of the changes, I need to figure out either if they are adding the same amount, subtracting the same amount, or multiplying or dividing by the same amount. So my linears will add or subtract the same amount every time. The exponentials would be multiplying or dividing by the same amount each time. So I'm going to start by drawing in blue and trying to see what the change is by adding or subtracting. How different is it to get from -6 to -24, and then to -96, and then to -384? So I noticed very quickly my change from -6 to -24 was -18. We went down 18. From -24 to -96, we went down 72. So I noticed very quickly this is not a linear function, because for that our change would have to be the same each time, and we didn't subtract the same amount both times. So now I'm going to erase that and check if this is exponential by dividing. So as I looked at my y values changing from -6 to -24 and then to -96 and -384, I'm checking if this is exponential by dividing the two y values that are next to each other. So I was able to say to go from -6 to -24, that means -24 over -6, that was multiplied by 4, or in other words, when I divided, I got a result of 4. And then I again noticed that -96 divided by -24 also gave me a result of 4, which means that -24 multiplied by 4 would give me my -96. And while I didn't draw it, the -384 divided by -96 also gave me a change of 4. So that means that every single y value we increase, we're multiplying by the same number. That number is 4. And that does make this an exponential function. So to complete these problems, you'll tackle the rest of these the same way. All you need to do is check and be sure that the x values are increasing by the same amount. I'm pretty sure they do. And your y values are increasing in the same way by the same amount. Those two ways, again, can be adding or subtracting the same amount each time, which would be linear, and multiplying or dividing by the same amount each time, which would be exponential. And we do this by comparing each of our y values, how we get from one y value to the next. And you do need to check both, because you need to keep in mind that neither is an option. So that means you do need to check all of the steps for each of your changes, each of the y values. And of course, if it doesn't match one, then it's certainly not that one, but it doesn't mean it is the other one, because neither, again, was an option. So check each of your changes, and you should be able to complete this assignment with no problem. One last thing, don't forget, Google can act as your calculator.